Hello team, in this lesson we are going to learn different types of queries in JPA. We are going to start the lesson from the overview of different JPA queries types. Namely, we'll review such types as query, TypedQuery, NamedQuery, NativeQuery, and Criteria API. During the lesson I will explain what a JPQL is and what its key features are. To help you with debugging of your programs when using JPA, I am going to show you one more property that would enable logging of SQL queries executed against database. And also, we're going to have a lot of practical exercises today during the lesson. Let's start our lesson. Today we're going to learn different types of queries, like I said. Some of the queries will be created with the help of the JPQL. We are going to learn today what it is and review examples too. Some queries will be written on pure SQL, but still JPA will be used to execute these queries. And also we are going to learn Criteria API to learn how to create queries programmatically. So to sum it up, in JPA we have the following types of queries. Query written in Java Persistence Query Language, that is JPQL syntax. There are two additional query subtypes. They are TypedQuery and NamedQuery. The next query types are NativeQuery, written in plain SQL syntax, and Criteria API query, constructed programmatically via different methods. To understand and work with all different types of queries, we also need to learn JPQL. Let's learn first what it is. JPQL stands for Jakarta Persistence Query Language, or Java Persistence Query Language. It is an object-oriented query language which is used to perform database operations on persistent entities. Instead of database table, JPQL uses entity object model to operate the SQL queries. Here, the role of JPA is to transform JPQL into SQL. Thus, it provides an easy platform for developers to handle SQL tasks. JPQL is developed based on SQL syntax, but it won't affect the database directly. The general structure and syntax of JPQL are very similar to SQL. Having a SQL-like syntax in JPA queries is an important advantage because SQL is a very powerful query language and many developers are already familiar with it. So, to sum it up, the main difference between SQL and JPQL is that SQL works with relational database tables, records, and fields, whereas JPQL works with Java classes and objects. For example, a JPQL query can retrieve and return entity objects rather than just field values from the database tables, as with SQL. That makes JPQL more object-oriented friendly and easier to use in Java. The key JPQL features are: it is platform-independent query language. It is simple and robust. It can be used with any type of database, such as MySQL or Oracle, it doesn't matter. JPQL queries can be declared statically into metadata or can also be dynamically built in code. We learned what a JPQL is, and before jumping to examples, let's learn a little bit more theory about Criteria API, and after that I will walk you through all the examples. The Criteria API is one of the most common ways of constructing queries for entities and their persistent state. It is just an alternative method for defining JPA queries. Criteria API defines a platform-independent criteria queries, written in Java programming language. It was introduced in JPA 2.0. The main purpose behind this is to provide a type-safe way to express a query. The Criteria API is a predefined API used to define queries for entities. It is the alternative way of defining a JPQL query. These queries are type-safe, portable, and easy to modify by changing the syntax. The major advantage of the Criteria API is that errors can be detected earlier during compile time. String-based JPQL queries and JPA criteria-based queries are same in performance and efficiency. So it would be up to you which one you would like to use in your code. Okay, we learned enough theory to proceed with practical examples. Let me start screen sharing and proceed with code examples. All examples from today's lesson will be in the package queries. You will be able to find the reference to the source code examples in attachments to the lesson. During multiple examples today, I am going to use user entity from this package. Here it is. To avoid name conflict with other users that we created during the previous lessons, this user entity has specific entity name, and this is just for the sake of the example. As you can see, its name is user_queries_demo, and separately I specified table name, user_qd. I also did this on purpose so that you would be sure when we use table name and when we use entity name in our examples. This is important to know and understand, because when we will write queries today, we'll use entity name in JPQL and we will use table name in native queries. Let's start from review of the simple query. I open JPQL query demo class. In the main method, I create entity manager factory and create entity manager. Everything as usual. After that, I create user in the database, like we also always did. And after that, I call method getUser_by_id. And I pass ID and entity manager. And here I create query. So, to create query object, we need entity manager. Using entity manager, I can just call method createQuery and pass JPQL query. As you can see, it has SQL-like syntax. But instead of tables, we use entity names. As you can see, I reference the user_queries_demo entity by its name and assign the identification variable u to it. The identification variable is often called alias, and we already learned this with you in the lessons about relational databases. It is similar to a variable in your Java code that you can use later in the query. For example, here, in the where clause, I use u as a reference to the entity name and its ID property. So, you can see this alias in all other parts of the query to reference this entity. As you can see, in JPQL I can use parameters placeholders. I use colon and parameter name, like with ID here. After that, I can use method setParameter to set parameter to the query. And after that, I call method getSingleResult. I encourage you to review the source code of query type and its methods. Because, for example, in case we wrote our JPQL query and we expect multiple users to be returned, we can call method getResultList. That would be needed in case you want to retrieve all users. Let's get back to our example. Let me run this program, and as a result, we see that user that we created is printed to console. So, as you can see, JPQL syntax is pretty intuitive if you are familiar with SQL, and if not, please refer to my lessons about SQL in my course Java from Zero to First Job. I even thought about to show you other JPQL examples during this lesson, but when I created those, I decided not to confuse you, because they are absolutely similar to SQL query. The only thing that is different is that I use name of my entities instead of the table names. And when I refer to some entity properties, I refer to the entity attribute by their names, but not to the columns in the database. So instead of using column name from the database, just use properties named from the Java entity. Another difference is the possibility to use placeholders for parameters, like you already saw in example. That's it. In case you would have some challenges or open questions, please let me know in comments below the video and I will be happy to answer. Another important thing for you to learn during the development. If you use Hibernate, you can add property to show SQL queries that are sent to the database. This is important sometimes to use during the debugging. For example, when you want to make sure what exact query is sent to the database. I open persistence XML to add one more additional configuration. The property is called hibernate.show_SQL. We need to set it to true if we want to see generated SQL statements in the logs. You can find it commented here, so feel free to uncomment it in the source code examples that I will share with you. And let's run our program one more time. As you can see, there are queries in console. So in case you would face some errors and you can't understand why code doesn't work as it is expected, then please enable this property and explore logs. For now, I will comment this property back. Pay attention also to another thing here. Query can't identify what type will be returned. That's why we need to cast result manually to the type that we need. Because getSingleResult method returns us just object type, and that's it. The things are different with TypedQuery. I open another example that is called JPQL TypedQuery demo. TypedQuery is a separate type that extends query type. With TypedQuery type, I can specify the Java type that I want to extract from the database. TypedQuery is parameterized by the type that I want to work with, and when I call getSingleResult method, I receive the result of the type that I need. And I don't need to cast types manually. Let me run this program, just to make sure that we received our user object that we expected. Let's now talk about NamedQuery. I open another example here that is called JPQL NamedQuery demo. Imagine the case that in different parts of your application you use different queries. And you have a lot of different types and a lot of different queries, and gradually it becomes hard to maintain such amount of queries. But what if you could keep all queries that you use together with a specific entity in one centralized place and reuse them? Would it be easier? NamedQuery type can help us with this. Let me open our user class. Here on top you can see annotation NamedQuery. Basically, what we do, we map specific name with the query. Now, let me open JPQL NamedQuery demo class. In this class we have similar example. The only difference is our getUserById method. This time I use entity manager reference to call createNamedQuery, and I pass name of our named query. The rest things are similar here. I will just run this program, but believe me, we'll receive the same result. Named queries have some huge advantages. They are: named queries are compiled and validated when the persistence unit is loaded. We can centralize named queries to make them easier to maintain. For example, in ORM XML, in properties files, or in entity classes. Now, let's talk about native SQL queries. Obviously, JPQL syntax has some restrictions, and sometimes we want to optimize query execution and to use the whole power of SQL. This approach actually has its own pros and cons. Regarding advantages, we kind of talk through them. It is possibility to use the whole power of SQL and create queries specifically for the selected database, considering database dialect. But talking about disadvantages, you have to understand that using native SQL queries you can lose portability of your solution. By saying this, I mean that JPA serves us as an abstraction, and JPA takes care of compatibility with the database. Basically, you can just change the driver and dialect and configurations, and your solution can work with any other database. Using native SQL queries may be not so flexible. You should remember this. Using NativeQuery doesn't necessarily mean that our code works with only one specific database. I just highlight the risks. At the end of the day, if our queries don't use database-specific SQL commands, and we are using only a standard SQL syntax, switching providers of databases should not be an issue. But now you are warned. But in most cases, a good JPQL query can help us to solve our business tasks and, most importantly, maintain a level of abstraction from the actual database implementation. Let me open NativeQuery demo class. This is the same example that we already reviewed, but the getUserById method is slightly different. Basically, nothing complex in creation of native queries. You just call method createNativeQuery and pass native SQL query. That's it. Pay attention that this time we pass table name, but not entity name. Basically, that's it regarding native queries. My general advice would be, try to use JPQL queries when it is possible, or Criteria API, and only in case you want to optimize query execution, and it's really worth it, in this case you can try native queries. That's my general recommendation, but again, it is only up to you what you will decide to use. And finally, let's learn what a Criteria API is. Criteria API queries are programmatically built, type-safe queries. It enables us to write queries without doing raw SQL, as well as gives us some object-oriented control over the queries, which is one of the main features of JPA. The Criteria API allows us to build up a criteria query object programmatically, where we can apply different kinds of filtration rules and logical conditions. I open another example that is called Criteria API Demo. This is a similar example that we have reviewed, but I have few methods here written with Criteria API. Let's start from the simple one. Let's extract all users from the database. Even despite we created only one user, still, it will be useful for you to learn API how to extract all entities of the specific entity type. Let's review a method that is called getAllUsers. So, if you see Criteria API the first time, most likely it wouldn't look very friendly. But once you start use it, everything will become logical for you. Let's review this simple example. We use Entity Manager to get Criteria Builder. Using Criteria Builder, we create query. As you can see, to create query, I pass class of my entity here. After that, we use method from to create a query root. So this method creates and adds a query root corresponding to the given entity. And using this root, we'll apply different conditions. After that, I call createQuery on the Entity Manager and pass criteria query there. We use select method on our criteria query, and I pass the root corresponding to the given entity. That's it. After that, I work with query object to extract the list of results. Let's put our focus now on the method getUserById. Basically, we do almost the same thing, but in addition to select, I apply condition. I can limit results of the query by applying where condition. I call where method. Where method takes predicate. To create predicate, you can use different methods. For example, equals method creates a predicate that validates equality with the parameter passed. We can open Criteria Builder and just explore methods that return predicate to us. In the source code you can see NotEqual method that also returns predicate, is not null, is false, is true, and a lot of other methods here. I encourage you to look through the source code to learn this API better. I don't think that we need to stop on this too much, because names of the methods are self-describing. I believe that you are smart enough to understand what kind of condition is created based on the method name. And even in case some method would remain not clear, please do not hesitate to ask your questions below the video and I will be happy to answer. After that, we call get method on our user root reference, and we pass here ID that we need to compare. Root type extends from type, and from type extends pass type. So the get method is from the pass interface. This is not the pass from the Neo package that we already learned. This is pass from Jakarta Persistence Criteria package. It represents a simple or compound attribute pass from a bound type or collection, and is a primitive expression. Let's get back to our example. After that, we call method getSingleResult, and that's it. And we receive user object. There are different other queries that you can make using Criteria API. And here in commented lines, I left few more examples. Some of them are: extract users with ID greater than 1. Extract users where first name contains all. Extract users with ID between 1 and 5. Extract users with the first name in the specified range. Example of how you can chain expressions using different predicates. You just create multiple predicates, put them into the array, and after that you apply array of predicates. Such API also exists. Feel free to use it if you wish. Sorting example. In this example you can see that I sort in ascending order by name and in descending order by last name. You can explore these source code examples. Just take a look how I built predicates here and which methods I used. You can build similar predicates using my examples, or you can explore other methods in Criteria Builder type. Let's review now update example. We'll update email of our user. After I created Criteria Builder, I call createCriteriaUpdate method. I use set method to provide new value for email field. After that, I apply where condition in order to change email only for user where ID is equal to one I passed to the method. And after that, I create query and call method executeUpdate. That's it. Let me also show you example of deletion. I call createCriteriaDelete method. And after that, everything that you already saw in other examples. We add predicate here to make sure that only record where ID matched will be removed. So, at the first glance, we did a lot of other things instead of just making a call to the database. But remember that Criteria API is a programmatic way to build queries in the object-oriented manner. It reduces chances to make a mistake. Of course, there are some disadvantages as well, especially around more complex joins. So it is up to you which tool and what API to choose for building query. It will depend on the multiple things, but now you know how to use Criteria API to query database. That's all what I wanted to share with you today. Let's recap what we have learned in this lesson. Today we learned different types of queries in JPA. We learned such types as query, TypedQuery, and NamedQuery. Also, I explained how to work with NativeQuery type. And we saw a lot of examples how to work with Criteria API. After this lesson, you should have clear understanding of what JPQL is and its key features. Also, we had a lot of practical exercises today. You can find the reference to the source code examples in attachments to the lesson. That's all for this lesson. Thanks a lot for your attention. Have a great day and see you in the next lesson.